Okay, here's another version of L'Hopital's rule. So we're this time taking the limit as x approaches infinity of the natural log of x over 2 times the square root of x. Now, you can't really substitute infinity here, but we can try it to get an idea of what's happening. If we do that, we get the natural log of infinity over 2 times the square root of infinity. Well, the natural log of infinity is simply infinity, okay? And the square root of infinity is infinity, so 2 times infinity is also infinity. Infinity over infinity is another indeterminate case, similar to 0 over 0. We don't know what it means. And that means we can apply L'Hopital's rule. Okay? So it's an unusual one. It's more Calc BC, AP Calculus BC than it is AP Calc. But we're just doing it just in case. So if you see infinity over infinity, that's another indeterminate form, and you can use L'Hopital's rule. So if we do this now, apply L'Hopital's rule to that, the limit as x approaches infinity of log x, we're going to differentiate. So write this root x as 2x to the power of 1/2. And we're going to differentiate the top and bottom. So it's going to become the limit as x approaches infinity. Differentiate log x, you get 1 over x. And differentiate 2 times x to the power of 1/2. Multiply down by the power, 2 times 1/2 is 1. And it's going to be x to the power of negative 1/2. Okay, well, we should be able to rewrite this. And that would give you the limit as x approaches infinity of 1 over x on top, and on the bottom we'd have 1x to the negative 1/2 is 1 over the square root of x. Now I know it's getting a little bit crazy looking, but let's keep going. Now we've got the limit as x approaches infinity, and this expression here, 1 over x divided by 1 over the square root of x, we're dividing by fractions. So the way to divide by fractions is to multiply by the reciprocal of what's on the bottom. So 1 over x divided by 1 over root x is the same as 1 over x multiplied by root x over 1. Okay, well, that's going to be the limit as x approaches infinity of root x over x, which is the limit as x goes towards infinity of x to the power of 1/2 over x, which is the limit as x goes towards infinity of 1 over the square root of x. Okay? It's 1 over the square root of x. Now, again, we can't really plug in infinity because it's not a number, but we can try it to get a flavor of what that is. And if we plug that in, we get 1 over the square root of infinity, which is 1 over infinity. Now, if you think of a fraction with a number on top and this huge number on the bottom, okay, the number on the bottom gets big enough, the fraction basically becomes 0. So it's not equal to 0, but it basically is becoming 0. Okay, if the number on the bottom is big enough, then the whole fraction basically is 0. Not exactly 0, but basically 0. And when that happens with limits, we say 1 over infinity will give us 0. So therefore, our answer to this problem is that the limit as x approaches infinity of the natural log of x divided by 2 root x is equal to 0. Okay? And the thing to take away from this, something new to take away from this, is that 1 over infinity, or in fact any number over infinity, basically in terms of limits, when we're talking in the context of limits, becomes 0. Okay, and more so than that, it can be plus or minus. Okay, and like we said, it doesn't have to be a 1. Any number on top. Any number on top. In the context of limits is equal to 0. Okay. Okay. We can look at that in a little bit more detail. We won't spend too much time on it. But if you want an explanation for that, let's think about this function here. Let's say we take a function 1 over x. Very simple function, 1 over x. And let x get bigger and bigger. So let x get closer and closer to infinity. So 1, 10, 100, 1000, 10,000. Well, 1 over x would be just 1. 1 over 10 would be 0.1. 1 over 100, 0.01. 1 over 1000, 0.001. 1 over 10,000, 0.0001. Okay? And we can see that as x approaches infinity, 1 over x is approaching 0. Okay? As x approaches infinity, 1 over x approaches 0. Something that we've seen before, but worth reiterating now. So anything over infinity will become 0. Okay? Thank you.